In this video, we're going to look at angles in standard form and talk about the ways that we measure them. We'll start with degree measures and we'll introduce yourselves into what we call a radian. First, we'll look at the standard coordinate plane here. We have our x and our y axis. Now, angles are just made up of two rays put together at a vertex. The first ray has a name for itself, and it's going to start on the x-axis. That ray is called the initial side. The second ray, called the terminal side, makes up the angle, and the measure between those two we will call theta. That's the Greek letter theta, similar to us using x in algebra. That's our variable here if we do not know the measure. There are two types of angles that we have. We have positive angles. Positive angles are always measured in the counterclockwise direction, and we'll measure those going from the initial side to the terminal side. We also have negative angles. Negative angles will always go in the clockwise direction, again, always starting with the initial side, ending up at the terminal side. So the most common unit of measure that we have for an angle is called a degree, and 1 degree is known as 1/36th of a revolution. So we could break up that one trip around the circle into 360 individual degrees, and adding all those up, we get the full trip around the circle. And here is our circle on the Cartesian plane, starting at 0. Again, we start on the x-axis, and it goes counterclockwise, going up to 90, back to the negative side of the x-axis at 180, down to 270, and then one trip back around at 0, we get to 360. So just to look at some type of angle measures here, we have 65 degrees starting at its initial side on the x-axis. 65 has to be in the first quadrant. And then we look at 415. 415 still ends up in the first quadrant. Now that's one trip plus in the circle. And the way that we will use that notation is that we'll use a little squiggly line here that will start at the initial side and do one trip around, go past the initial side again, and end up at the terminal side. So there's some positive angles, and then we have our negative angles. Negative 15 degrees, we go 15 degrees below the x-axis, and negative 210 degrees, we go below the x-axis, and then some to make up 210 degrees in the negative direction. So that's degree measures. What the heck is a radian? A radian is known as the relationship between the arc of a circle and its radius. So let's look at where this comes from. The first thing we need to look at is we need to remember what the circumference is. And the reason why we use the circumference is it's easy to calculate given a radius, and we'll know the distance around the entire circle. The second thing is we're going to look at the unit circle. So this is a circle that has a radius of 1 unit, whatever that unit could be. So pulling that up, here's an XY coordinate plane and a circle, and we're going to call that radius right there from the origin to the yellow circle 1. Calculate the circumference of it. Well, we would plug in 1 for the R. Well, what that ends up giving us is just the circumference around the circle is 2 pi. Well, remember, one trip around the circle is 360 degrees, so we can form a relationship between this. We can say that 2 pi in circumference is 360 degrees, and treating the pi like it's a variable, we could simply just divide both sides by 2. Therefore, pi would be 180 degrees. So if I were to go in, start at my initial side, and just travel along this circle and stop 180 degrees in, that would be pi distance for the part of the circumference out of here. Okay, and that's helpful for us because what we can do now is we can convert degrees to radians, and then we can take a radian and convert it back to a degree. And they're pretty simple formulas. Here are the formulas that we have. If we want to take a degree measure and we want to go to a radian, we'll take our degree and we'll multiply it by the fraction pi over 180. If we want to take a radian measure and go to a degree, we take our radian measure and multiply it by the reciprocal of that fraction, which is 180 over pi. Okay, so let's convert some radians. Well, let's convert 2 radians. So here's our degree measure. We have 60 degrees. If we follow our rule, we need to multiply by pi over 180. And a way to think about this and to memorize this is think about canceling out fractions. We want something on top of the fraction to cancel out with the bottom of the fraction. And you'll see here we got the degree symbol on top, and we got the degree on the bottom, so that will get the degrees to cancel out. And multiply fractions, we go straight across. So that would give us 60 pi over 180. And in a sense, I'm just going to ignore this pi and look at the fraction that we have here of 60 over 180 and simplify it, which would give us pi over 3. So 60 degrees on the circle correlates to pi over 3 as a distance of the arc of that circle. The next measure, let's do a negative degree, 230 degrees. Well, the rule still stays the same. Let's multiply by pi over 180. We multiply straight across. We simplify our fraction of negative 230 over 180. And that simplifies down to negative 23 pi over 18. So there's the radian measures for those particular degrees. Let's go the other way with this. Let's convert a radian to a degree measure. Let's start with 5 pi over 180. The rule is let's multiply by 180 over pi. That's a flip of that fraction. So we see here we got a pi on top and the pi on the bottom. Those are going to cancel each other out, and we multiply straight across. 5 times 180 is 900. 18 times, which would be 1 since the pi canceled out. 900 divided by 18 is 50 degrees. So 5 pi over 18 radians is equivalent to 15 degrees. How about negative pi over 6? Multiplied by 180 over pi. Again, the pi symbols cancel out. Now we're looking at simplifying negative 180 over 6. Well, we simplify that. That is negative 30 degrees. So there we can convert some radians to degrees and degrees to radians. Next thing we will look at is coterminal angles. Coterminal angles are something that you do discuss in your geometry class, but let's remind yourselves of what a coterminal angle is. These are two angles that are said to be, or two angles are said to be coterminal if they share the same initial side and the terminal side. So really, it doesn't matter how many trips you make around the circle. As long as they share those two sides, they are called coterminal. So let's look at a visual example here. Say like 30 degrees. Here's where 30 degrees would be at on a Cartesian plane. If I go one trip around the circle, notice that I started at the initial side of the x-axis, went completely back around and stopped at the terminal side, this would be a coterminal angle. So if we calculated it, we're adding 360 degrees because we took a full trip around the circle. That would be 390 degrees. Well, we can go in the negative direction. We start at our initial side and stop at the terminal side. It looks like we don't make a complete circle out of this, but that 30 degrees from our original angle would make that full trip out of there. So we need to, again, subtract some amount from 360. Since we're doing a negative angle, let's subtract 360 from our original angle of 30. That would be negative 330 degrees. So those are what we would call coterminal angles of 30 because they share the same initial side and the same terminal side. All right, so let's determine if I give you two angles, are they coterminal or not? 305 and negative 55. Let's start with 305. If I just subtract 360 degrees away from this and I get negative 55, then I know that they are coterminal. I'll type that into the calculator, do some mental math. We do get negative 55 degrees, so these are in fact coterminal angles. Are 30 degrees and negative 170, are they coterminal angles? We'll start with our subtraction. 30 degrees, take away 360. Now we get a much smaller negative number than negative 170. Looks like these would be not coterminal. Pretty simple to do with degree measures, but can we do this with radians? Are 3 pi over 2 and negative 5 pi over 2, are they coterminal? Well, here's what we have to remember. Remember that 360 for degrees is equivalent to 2 pi, one trip around the circle? Well, if we're going to subtract 360 away from degrees, we would have to subtract 2 pi away for radians. So start with 3 pi over 2 minus 2 pi. The issue here is now we're working with some fractions. We don't have a common denominator. We need to rewrite 2 pi in a way that has that common denominator of 2. Another way to say 2 pi would be 4 pi over 2. Now we can take 3 pi minus 4 pi, and you get to negative pi over 2. Now you might say, well, that's not negative 5 pi over 2. Then you could say that they're not coterminal. But here's the problem. Negative 1 is larger, or negative pi would be larger than negative 5 pi. So let's subtract another revolution of 2 pi, because coterminals go on forever. Let's subtract another 2 pi, or 4 pi over 2. Then what you'll see here is that negative pi over 2 minus 4 pi over 2 is negative 5 pi over 2, and we do end up at this angle here. So it took 2 revolutions around the circle to find a coterminal angle for this, or define that they are coterminal angles. So yes, these two particular radians are coterminal angles. So we can say then, there are an infinite amount of coterminal angles. We can add or subtract any multiple of 360 degrees, or we can even do 2 pi from our given angle to find a coterminal one. So we can formulate this now. If I want to find any particular degree measure that's coterminal, I need to take my given angle, and I can add any multiple of 360 degrees. That k number is just how many revolutions you're wanting to go around the circle. The same thing can be said for radians. Our given angle theta plus 2 pi times any given amount of revolutions that you want to go around the circle. So if you're given an angle and you're asked to find a positive and a negative coterminal angle, we can just simply add or subtract 360 from it as many times as we want, or we can add or subtract 2 pi from it as many times as we want. Let's start with a degree measure. Well, here's 150. It says give a positive and a negative coterminal angle. Let's go with positive. So we'll add 360 to 150, which is 510 degrees. So there's one coterminal angle, and it's positive. The negative angle, 150 minus 360, will give us negative 210. Again, these are not the only 2 coterminal angles that we have. If we would really want to, we could add or subtract 360 from those angles again a second time, and this would give us 2 more coterminal angles for 150, which would be 870 and negative 570. Okay, let's do a radian. 7 pi over 6. For the positive angle, since we're doing radians, we need to add 2 pi. Again, this does not have a like denominator. We need to write an equivalent form of 2 pi. And I kind of cheat here. I look at my denominator here, and I need a 6. So I can multiply 2 pi by 6. And I'll get 12 pi over 6. Now I can add 7 pi plus 12 pi, which give me 19 pi over 6. The negative, let's subtract away 2 pi. Or in other words, subtract away 12 pi over 6. 7 pi minus 12 pi will give us negative 5 pi over 6 for its coterminal angle. And there are just 2, a positive and a negative coterminal angle for 7 pi over 6. Just like we did in the previous example where we could add and subtract 360 again to get more coterminal angles, we could add or subtract another 2 pi, or add or subtract another 12 pi over 6 to get 2 more coterminal angles. And that would give us something like 31 pi over 6 and negative 17 pi over 6. So here in this video we talked about what makes up the angles, how do we know what an initial side is, what a terminal side is, positive and negative angles, how to convert from degrees to radians, vice